Welcome to another deep dive. Today, we're plunging into the really fascinating world of the online encyclopedia of integer sequences, the
Right.
OEIS. It's just an incredible resource, especially if you're a number theory student or, well, anyone interested in patterns and numbers. Our mission today, to unpack A000280. Now, this is a sequence that it starts off simply enough, but then it quickly, well, it really explodes.
It really does. It's quite a marvel, actually. The sequence is defined by this recurrence relation, an equals an1 plus an2 cubed.
Okay, AN1 plus AN23.
Precisely. And what's immediately striking, I think, is that cubic term, that an2 cubed.
Right.
Most common sequences you might run into, maybe like Fibonacci, they just rely on simple addition.
Sure.
But that cubic factor here, it really sets this one apart. It signals something pretty profound about its behavior right from the start.
That cubic term definitely stands out. Okay, maybe let's walk through those first few terms just to get a feel for how it plays out.
Good idea.
So it starts 0, 1, 1, 2, 3, 11, 38. Looking at those numbers, I mean, it seems manageable, almost unassuming, really.
Yeah.
You can, pretty easily follow the rule and see how those first few values pop out.
Yes, but that apparent manageability, well, that's exactly what makes its later growth so astonishing.
Okay.
What's fascinating is just how rapidly it leaves manageable behind. While the first few terms are small, this sequence very, very quickly becomes enormous.
How enormous are we talking?
Well, to give you a sense of scale, the renowned mathematician Harvey P. Dale, he noted that just a few steps past the terms you listed, the term A12.
The 12th term.
The 12th term, yes. It has a staggering 85 digits.
85 digits?
Yeah.
Wow. That's not just big. That's the kind of number where, your standard calculator just gives up.
Exactly. It throws an error.
That really drives home how fast these numbers balloon.
Right. Yeah.
Is that typical for recurrence relations, or does that cubic term really push it into sort of another league entirely?
Oh, it absolutely pushes it into another league. Sequences that grow this explosively, they present really unique challenges, both in computation and in analysis.
I can imagine.
Understanding why certain recursive rules lead to these astronomical scales, well, that's a crucial frontier in number theory. It often requires pretty advanced techniques even just to approximate their behavior.
Okay, so we've seen how it grows, how incredibly fast. Now, the real question, I suppose, is why? Why does it behave this way?
Yeah.
What's the sort of mathematical engine driving this acceleration?
That's the core question, and this rapid acceleration is actually captured quite well by its asymptotic formula. This was provided by Vaclav Kotesevic. It shows that an grows approximately as c raised to the power of 3 raised to the power of n over 2.
Whoa, okay, wait, c to the power of 3 to the power of n2.
Precisely.
Yeah.
Where c is a constant, it varies slightly depending on whether n is even or odd, but the dominant factor, that 3n2 in the exponent, that's exactly what causes the values to just skyrocket. Think of it as, well, exponential growth on steroids, maybe, where the steroid itself is also an exponential function. That kind of nested exponentiation is incredibly powerful.
So just to make sure I'm getting this.
Yeah.
It's not just exponential growth. It's like super-exponential because the exponent itself is growing exponentially.
That's a good way to put it, yes. Super exponential, it really underscores how quickly these numbers just balloon beyond comprehension.
Okay, that makes sense.
And, beyond just its mind-boggling growth rate, the OEIS also helps categorize A000280 with specific keywords.
Like metadata for sequences.
Exactly. For instance, it's labeled non.
Non.
Yeah, N-O-N-N. It just means it exclusively contains non-negative integers.
Okay, simple enough.
And that simple keyword. It's actually part of how the OEIS, this incredible digital library, helps mathematicians quickly filter and categorize. It tells us immediately, okay, we're dealing with integers that never dip below 0, which, isn't always a given with complex recurrence relations.
Right. Some sequences can go negative.
They can. And A000280 is also cross-referenced. It links to sequences like A000278, for example. This shows its place within the intricate tapestry of number theory sequences in the OEIS.
So you can see connections.
Yes, this cross-referencing is invaluable, especially for researchers looking for connections, patterns, maybe similar behaviors across different kinds of sequences.
So wrapping this up then, what does this all mean for us? Or for someone studying number theory? This deep dive into A000280, it really shows vividly how a simple, kind of elegant recursive definition
Yeah.
Just adding that one cubic term can lead to numbers that grow at an almost incomprehensible rate. It really pushes the boundaries of what we can even, compute or grasp intuitively.
It certainly does. And this raises, I think, an important question for you, the listener, to maybe ponder.
Yeah.
How do such fundamental, seemingly simple rules in number theory consistently lead to results of such immense complexity and scale?
That's a great question.
And what more might we learn by exploring these extreme growth patterns? Not just as mathematical curiosities, but maybe as keys to understanding the very fabric of numerical systems themselves.
It's a powerful reminder, isn't it? That even the simplest starting points in math can lead to just infinite depth and complexity. We definitely encourage you to explore the OEIS yourself. Go on, discover some more mathematical wonders.